So I picked up this little Kenwood on Craigslist. It's a model KR-4070, about 40 watts per channel, kind of a mid-tier receiver. Built these between 77 and 1980. Pretty basic unit. Most of the features you expect to see on something like this. Your power and headphones, speaker switch is integrated into one rotary knob. Bass and treble controls, which are both dented. And your balance control, which is dented in the center. Got your volume control here, which is smooth. And then we've got our loudness buttons and also our tape source and play for duplicating tapes and such. And then we've got our mode switch here. And our tuning knob, which, well, doesn't spin very freely. Looks a little bent too. Let's see if I can try to straighten that out. So looking at the back side of this thing, again, we've got our typical outputs. Let me get that out of the way. So we've got our phono input, auxiliary, our ground for the phono, and then we have our tape play and record outputs. Then you get your 5-pin DIN connector there for tape decks that are equipped with such a connector. Got a couple of AC outlets, one switched and unswitched, and then you got your 4 speaker outputs, right and left for channels A and B. And that's about it. So let's have a look under the hood. There are the guts exposed. And this is laid out kind of nice. It's got 2 main boards. You've got this main board here, which obviously has the tuner section on it, and probably some other tone controls and switching. And over here you've got the preamp section and the power output section. And here you've got the power supply and the mains transformer. A couple of fuses. Got a bridge rectifier right here, really simple. A lot of scunge on this board though. Would be a lot of cleanup with this this particular unit. These 2 filter caps have been replaced. They're brand new, and they're Nichicons, so those are nice caps. We'll hang on to those babies. And let's go over here to the tuner section. If you look, it's really dirty inside of here, and there's quite a bit of rust as well. And you can see it here on the shielding and on the tops of the cans. Tops of the capacitors are dirty, so there's going to be a lot of cleanup work. Like, I'm going to have to replace that guy because he's rusted up, and that guy's rusted up, and so I'll just replace those. I'll do a whole recap in here. And another curious thing, if you look down right here, see these 2 resistors right here, R67 and R66. You see that little black patch? These are what's known as printed resistors, and I think it's something that they experimented with for a while, and they print the resistive material directly onto the circuit board. And they've got a handful of these in here, and I just think it's kind of weird how they did some and not the others. You think they would just do everything that way or nothing that way, but like I say, I think it was an experiment. And so if these things fail, then you just basically put a common resistor in its place, solder it into the holes, and you're done. So let's have a look at these output transformers. Transformers, did I say? I meant transistors. So what I'll probably do if I have to replace these, and I probably will have to replace them, is I'll get a modern equivalent that will have a different case style. So I'm likely going to have to drill and tap this heatsink. What some guys do is they take these existing transistors and they cut the legs off, and they just use the brackets, and they put the bracket over the top of the new transistor and put some longer screws in there to clamp down on it. I don't know if I'm going to go through that. I'll probably just re-drill the heatsink for the sake of it looking decent. But anyway, I'll check those and see if they're good or not. Let's look around here. And there's been some other work done on this as well. Right here, brand new cap right here. That's a Elna 2, which is an audio cap. It's a really nice cap. This one right here is new. Looks like this one here has been replaced. So there's been some work done on here. So hopefully nothing's too bad or nothing got screwed up. Obviously somebody was trying to figure out what was wrong with it and replaced a few caps, and that didn't quite get it. I think the first thing I'm going to do is I'll plug it in and I'll take a DC offset reading from the speaker terminals. Ideally we want to see 0 volts, and so before I plug anything at all into this thing, I want to see if we're getting any voltage out of the speaker terminals, and that will give me a good idea of what kind of shape this output section is in. So here's the setup. I've got the device set in auxiliary mode. Over here I've got all the bass, treble, and balance centered. I've got the volume turned all the way down. Loudness is turned off. I have no input going into this at all. So we should expect to see on the output of the speaker terminals 0 volts. So if there's any DC voltage riding on there, That shouldn't be there. Acceptable levels should be anywhere up to maybe 120, maybe 200 millivolts. Even that's pretty high, but I mean that would be decent. It'll give you a little bit of distortion on lower sound levels, but you know, that would be doable. But anything more than that then is an indication of a serious problem of balance somewhere early on in the circuit. So let's go ahead and turn this on. So we're going to phones, turn on speaker power. It looks like the stereo light's on, but that's just light pollution from the back of the unit. But all the other lights seem to be working, which is kind of nice. And let's see. So, all right. So we got 15 volts DC on the speaker output. So I sincerely hope nobody tried to hook speakers up to this thing. So that's on one channel. Let's go ahead and check the other one. I'll try to move my probes here. Okay, there we go. There's the other channel. And yeah, same thing. 15 volts on the output. So yeah, I'm definitely not going to hook any speakers up to this thing. So next thing I'm going to do is I'm going to unsolder the legs on the output transistors. I'm going to check them with my transistor checker, make sure there's no shorts or opens, and make sure they're okay. And then I'm also going to measure the pads and check different voltages around the circuit, kind of see what we've got going on. I've got the legs of the output devices desoldered, and so I've got my component tester hooked up to one of the devices. I'm going to take a look and check these to see if they're good or bad. Let's see what we got here. So first device, testing, and okay, so we got just about a direct short between pins 1 and 2, and it's identified as two diodes that are face to face. It's not even identifying it as a transistor. So this device obviously has an issue. So let's move on to the next one. Oops, I missed. 1, 2, and 3. I know this is riveting video here, folks. Try to stay in your seats. All right, device number 2. And looks like we got a direct short between pins 1 and 2, and pin 3 is not even recognized. So that device is obviously bad. Now I don't know if he replaced all 4 of the devices on here or if just one channel. Hopefully these 2 are not the new devices that he bought, because he told me he bought them off of eBay, paid a premium for them. And I'm always leery about doing that because it's really difficult to know whether you're getting a legitimate device or not, especially when it comes to a transistor. And if you don't have a tester like this to be able to test them before you install them, it's even more risky. And that's why I always prefer to just adapt a modern device to it, even if it's not the same case style. So let's see this one. All right, that one's identified correctly. It's an NPN. It's got a beta of 46. And so that one looks fine. Check the next one. Last one. Come on, you. Got it. Okay. Let's check this one. And this one shows as a PNP. And it's got a little bit of a higher beta, but that transistor looks good. So this is the one complementary pair on one side, and these transistors are good. So there's one good pair, one bad pair. So that means I'm going to be replacing both pairs with modern equivalents. So what I want to do next, because we had one good pair, one bad pair, yet we still had a 15 volt DC output on both channels, even with the good transistors in there. So with the transistors disconnected, I'm going to turn this unit on. I'm going to take some voltage measurements there on those pads and see what we get. So I've got my guy going to my Triac and my current limiting device. And let's go ahead and power this thing up. Put it on speaker A. I got my voltmeter right here, grounded to the chassis, and let's check this first one. So this middle pad, I believe, is a collector, and we should have rail voltage there, which we do. And the next one, yep, positive rail voltage. Next one's going to be positive rail voltage, and the last one will be negative rail voltage. Okay, and that's what we'd expect to see in the collectors. So let's check the other two pads. I'm not sure which is base and which is emitter. but they both should be close to 0. And we've got 15 on that, 14 on that one, the next transistor, 15 on that, 15.84 on that one, next transistor, 15.18, and 15.77, and the last one, 15.16, 14.69. So yeah, there's a problem earlier on in the circuit. So I'm going to have to go back a little ways. I'm going to print out the schematic so I can kind of figure out where my test points are. I'm going to check some voltages up a little farther in the back of the circuit and see where these strange voltages are coming from. But I still wanted to continue doing an analysis of this unit and its functionality. I wanted to look at the FM tuner section, and also wanted to monitor the output of the headphone jack, because the headphone jack actually worked when I went to go purchase this. I was able to hear music through it, so I know that that works. So we'll start with the FM section, and as you'll notice, the stereo light is on. So that tells me that the pilot signal is being detected and decoded through the FM section, so that makes me happy. And let's bring up some volume here. Okay, I know who that artist is, and I know what the song is, but I'm not going to say it. So that's great. That works good. And so if we go off the station a little bit, you can see the stereo light goes out, and we go back in, and it comes back on. Now, obviously, that should be centered at the strongest signal. So the receiver does need alignment, but it does work, and that's great news. So let's go ahead and check out a 1 kilohertz tone. I'm generating a 1 kilohertz tone from my service monitor right there. 1 kilohertz at 100 millivolts out. And so the red cable is my output of the signal generator. It goes into the left-hand channel of the audio input jack on the back. And then I'm monitoring the headphone jack via this cable, hooked up right here, as you can see it. That goes around to the back of my voltmeter where I'm measuring AC volts, and that comes back around to the input of my scope so I can monitor the signal, and then ultimately terminates into the input of my service monitor. And in this mode, it acts as an audio analyzer, and I can check distortion and sine nav and other neat things like that, which I'm not going to do right now. I'm just interested in looking at the signal to see what kind of shape it's in. So let's go ahead and switch this thing over to auxiliary, and let's turn up the volume and have a look at that signal. Right, so that looks pretty clean, and that's very encouraging. So despite the problems with the output section, it is passing audio, and it's not adding any other distortion components to the audio. So that's a good thing. Let me turn this down so we don't have to listen to that. Very good. Okay, so if I adjust the balance, I'm going into left-hand channel. So if I adjust it to the left, I suspect that the signal will be there, and that it is, as it is. I'm at the center now, going to the right, start to fall off a little bit, and it's kind of crusty right there through the range. So obviously this control needs some cleaning, but the control does work. So that's great news. So anyway, I'll get on to the troubleshooting now. I kind of suspect a couple of areas. We've got our differential amp section right here and right here, and those help to control the DC offset, as do these bias transistors, as do the current mirrors. So I'm going to check in this area right here. I'm going to measure voltages. I'm going to check transistors and see what's going on and see what's causing that 15 volts to appear right here on the outputs. And once I determine that and fix that, then I'll go through and start to replace capacitors. I may even replace most of the active devices in this circuit. They're all kind of pushing about 40 years old now, and I'm sure having some new silicone in here is going to benefit this unit. And transistors are pretty cheap, and so I think it would be a worthwhile endeavor to go through and replace most of these anyway. Definitely replace all the electrolytic capacitors and the tantalum capacitors. And if I find anything that's in the audio path, say this one right here specifically, I'm going to replace those with audio grade capacitors, sorry. And then if I have any tantalums, I'm going to be replacing those with quality electrolytics. And if I have any electrolytics that are at 1 microfarad or below, I'm going to replace those with equivalent film caps. So that's going to be my procedure. So let's see how it goes. Stay tuned. So I did some troubleshooting off camera, and I measured voltages on parts of the circuit that I suspected, like the current mirrors and the other balanced portions of the circuit. And I am finding voltages that show those sections out of balance. I pulled a couple of the transistors, I've checked them. They check to be okay, but that's not a guarantee, because sometimes transistors will check okay, but then once you put them in the circuit, they might be leaky or noisy or cause some other problems. But before I go ordering a bunch of transistors, I already have all the capacitors here in stock, and I'm going to replace them anyway. So I've decided what I'm going to do is go ahead and just recap this output section and the preamp section. And then I'll check the circuit again, and we'll see if it's come back into balance. These capacitors are somewhere around 40 years old. They do get leaky, and they do change tolerance. Sometimes they short completely. And there's quite a few of these that are right along the high voltage power rail within the circuit. And if those are leaky or shorted, then it's going to cause some problems. So I want to replace those and check out the circuit again. Now, if it still has an issue, at least at that point I'll know what it isn't, and then I can go ahead and continue checking the active devices and the rest of the circuit. Now, I don't typically like to shotgun things like this, but I think in this case it's going to be easier on me to do it this way. This is delicately balanced circuit, and so I think by eliminating the possibility of a bad capacitor, it's going to aid in my troubleshooting. So I'm going to go ahead and recap this, and then we'll come back and check out the circuit and see if it has corrected itself. So I went ahead and pulled out the heatsink that houses the output devices, and I did this for two reasons. First reason was just to be able to get better access to this board as I'm replacing the capacitors on it. And it was pretty easy to do, just had to remove this screw and that screw. And of course you got to desolder the output devices, which we did earlier when I was testing them. And then there's two thermistors that attach to the heatsink. Thermistor 1 and thermistor 2. I desoldered both of those leads, and then I supported it from the bottom as I removed the screws and slowly dropped out the heatsink. And there it is. So the second reason I pulled this heatsink out is the new devices I got. Let me straighten this out. This is a TO220 package. And this package, I don't remember what the official name for it was, but the slang term is a batwing transistor. And they don't make this package anymore, at least not on new devices. You can pick up used devices, but like I said earlier, I don't like putting used devices in equipment that I work on. So I'll be taking these off. I'll be drilling out the heat sink and tapping out the hole so it can house this transistor. And so that was the second reason I took this out. You also notice that I left these thermistors connected here, and there's a reason I do that. So, and I've explained this in another video. Okay, sorry about that. Some guy just rode by in a scooter and made a whole bunch of noise. But anyway, these thermistor things, they're very delicate right here at the body. And if you leave this, if you undo these from the heatsink and you leave them flapping in the breeze while they're soldered in the board, there's a good chance you're going to bust them off right here at the base. And if you do that, you're going to be pretty bummed out, because these are basically unobtainium these days, and you're going to have a really tough time finding another one. They were made specifically for the receivers that they were put in, and you'll have to get into the used market, and you'll probably pay a premium for it, and you'll have to wait for them. And there's no guarantee that they're going to work. So I always try to err on the side of caution and put the least amount of stress on these leads as I can. So when I actually go to work on this heatsink and remove these devices, drill them out and tap them, I'll take these out carefully, I'll store them, and once everything's done, I'll put them back and reassemble this in the reverse order that I took it out. So let's go ahead and keep on working on the recap on this board, and we'll see what happens after that. Okay, the recap on the output board is finished. And I'll give you a quick little flyby here. You can see the film caps that are replaced, and you can see the two audio caps that I installed at the inputs. You might be asking yourself, well, what in the world are these big monstrosities right here that they just don't match? They look like the old caps. Well, it's because I had to put those old caps in. You know, I had the proper value in stock. It was the right voltage, but I'll be darned if these were not non-polarized capacitors, and I didn't have any NPOs in stock, so I had to order those, which is fine, because I also have to order these trim resistors because I want to replace those as well. These are pretty scungy, and they're known to be somewhat unreliable. So this section's all finished. Plugged it back in and checked the voltages again. Unfortunately, the circuit is still way out of balance, so putting the new caps in there didn't solve the problem. But like I said earlier, at least I know what it is not. It is not the capacitors. So good news is the circuit is back in balance, and I'll show you how that came about. I'll flip this over here real quick. Grab the schematic. So I decided to start checking voltages, and I wanted to start back at the beginning of the circuit. So the end of the circuit is here. This is where we should have 0 volts, and we're seeing like 15, almost 16 volts. And here's the input of the channel. And Kenwood's really nice where they kind of they map out the audio path, so you can see where the audio path is and how it gets to the circuit to the output. That's pretty handy, especially when you're replacing capacitors. That way I know that this is directly in the audio path, so it needs a good quality audio cap. Anyway, getting back to the circuit, so the first thing I checked was the differential amp section. I measured the voltages across here. They weren't exactly what they were supposed to be, but they were pretty close. It wasn't blood and guts. So I thought, okay, well, this probably is not the culprit. But that wasn't the case when I got to the current mirror circuit. So what the current mirror basically does is your current is set up in this device right here by this resistor. And the way the circuit is set up, this section here will see or mirror the same current that this section sees, regardless of what the changing load is. And they use that for the bias circuit and to stabilize it and give it a constant current. Now there's other methods of doing this. On other amplifiers you'll see that they'll put diode stacks right here off the base, and that's the way that they regulate the current. This one's a little more complicated, but unfortunately with more plumbing you have the possibility of more problems. So I checked the voltages around here. It's supposed to have negative 37 here, you're supposed to have negative 37.5 here, negative 1.2 and 0.56. They were way off. One of this current mirror I think was, or this main current source I think was off. This transistor was off. This one was in saturation, so this thing was all screwed up. So I thought, okay, well, let me desolder the legs or the bases, and I'll check the voltages once I take these kind of quasi out of circuit. So I desoldered the legs, I measured the voltages on the pads, was pretty much the same regardless of whether or not the transistors were in circuit or not. And then I actually checked the leg of the transistors, and the measurements were weird there too. So I thought, okay, well, let me pull these out and check them and see if they're good or not. So I pulled them out, I checked them, they were both good. I put them back in the circuit, and lo and behold, the thing went back into balance. So it was kind of a happy accident. I can't explain exactly what happened. The only thing I can logically think of is I know there was somebody in this receiver before, and when I took these out and cleaned up some of the solder, put them back in, maybe I repaired a solder bridge that was there that I didn't know was there. Well, it's been a few months and I'm back with this Kenwood KR-4070. I finally got it sorted out. Okay, it's been on the shelf for a little bit because quite honestly I got frustrated with it. I recapped it, and then it fixed itself, and then it unfixed itself, and so I needed some additional transistors that I was suspect of, and I had to order those. And then I got some other projects coming up. Long story short, it sat for a while, but I had some time to work on it today, so I thought I'd bring it down and take another crack at it, and we got it all working. So let me show you what I found. So initially when I got it, the output transistors were bad, and then we had a huge DC offset on the output. So where this should be 0 volts when you have no signal going through the amp, this was sitting at 15 volts. And it was the same exact thing for the other channel right here, should also be 0 volts. Okay? So I suspected the differential amp, and I also suspected the current mirrors as well. So I replaced this pair with a match pair, I replaced this pair with a match pair, and I did the exact same thing on the other channel. Fired it up, same exact problem. So I'm like, okay, so what do we need to do? I start checking voltages everywhere. The thing that was curious is it's the same exact problem on both channels. And so when I checked the voltages here, I had 0 volts here, I had 0.6 here, and I had 0.5 here, and that was throwing off the balance on this side. I had the exact same thing over here. I had 0, 0.6, and I had 0.5 here, which is throwing this side off in the same way. So I thought that was really strange. So it must be something that's in common with both of these. So I started looking around on the schematic and discovered that the common denominator between those two is this 39 volt rail line. So this feeds the output transistor, the positive one. It feeds the driver. It feeds this circuitry down here, which is some protection circuitry. it feeds this rail down here, and it also feeds this right here, and also goes back and feeds this diode and goes back to this part of the circuit. So what I was seeing, I had 39 volts here, this was fine, and this was fine, but all the other rails were pulled down. This was pulled down to 9 volts. This was pulled down to 9 volts. This was pulled down to probably about 8.5 volts. And then all the way down here, it would go through this Zener diode, and on this side I only had 4 volts. This is a 14 volt Zener diode, so I should have full rail voltage here, and it should be regulating this line to 14 volts. It wasn't. So what did I do? What do you think I did? Here's what I did. I isolated this resistor right here. I desoldered it here, and then I checked the voltage behind here. It did pop up. It didn't pop up to full rail voltage. It popped up to 30 volts. Still had 39 here and here, but I had 30 volts here, I had 30 volts here, and then there was nothing on this side. Soldered it back. This dropped back down to 9, this dropped back down to 8, and this was still sitting at 4. I thought, okay, so maybe there's something in common after this point that's pulling down the circuit. So I isolated this, was the same. Took the Zener out, it was the same. This cap, even though I recapped all the electrolytics on this before I started this whole exercise, I pulled that out just to make sure everything was the same. Isolated this, it was the same. I went back here, isolated this whole circuitry, still the same, it was still down. But I could go back here, and this was sitting at 39, and this was sitting at 39. So this is driving me nuts, because as you can see, there's a straight line going all the way across that feeds all the circuitry. Well, let me show you what I found. So I'm looking on the board, and I'm desoldering things, I'm looking for components. The good thing about this service manual is it has a board layout included. So I'm looking at the board layout to find where these parts are. So you can see the similarity. So the schematic actually gives you the electrical diagram, how it's wired up. The board layout actually shows you where the components are with respect to location on the board, and kind of how they're put together with the different legs and the different traces and whatnot. So where are we looking? So let's see. Let me find it. Let me find it. Here it is. RM88. So this is RM88 right here. 4.7K. I measured that resistor, by the way, and that resistor was fine. So what I found is when I isolated it here, I isolated both this diode and this. So everything back from here should have been measuring full rail voltage. I was getting 30 volts here. Okay. So if you look back at the schematic, which I will take you to, this was seeing 30 volts, right? And this was still seeing 39 volts. So let's go back to the board layout. RM88. So here's the side that was at 30 volts. Well, if you follow this leg up here, you see this little via that connects up to this part. Okay? Here's the collector of QM16, which measures at 39 volts. So this goes down here, and this little via, this via right here, connects this 39 volt rail over to RM88. And so what was the problem? This via was no good. There was a high amount of resistance going through this via, and it wasn't allowing the full amount of voltage to reach this spot right here. So what I did is I took a little clip lead, and I clipped the collector right here, and I connected it directly to this back side of RM88. Boom, circuit came up, everything was balanced. I had 0 DC offset at the back. I'm like, oh my goodness, I can't even believe it. So that was a problem, folks. And let me tell you, that took me a good 2.5, almost 3 hours to get through the troubleshooting steps on that. So this right here was my fix. So there's the 39 volt rail line. So I skipped over the via, and I just connected from here to the back side of that resistor, and everything is playing nicely now, and the circuit's all back in balance. How about that? So whew, boy, that was quite a challenge, folks, let me tell you. Anyway, what's left to do on this? Okay, so I have to set the I got to set the bias on the output transistors, because I haven't done that yet. And I need to check the DC offset at the output, which should be fine because I replaced both the differential amp and the current mirrors, both with matched pairs. Now, this doesn't have an adjustment for DC offset, so you got to be careful about when you're beta matching those transistor sets. And I actually covered that in another video where I did the same thing on a Pioneer receiver. So I'm going to go ahead and do that, and I'll be back with the setup for the bias setting on this thing. Stay tuned. Okay, so I'm ready to set up the bias on this thing, but real quick before I do that, I just wanted to go over some of the parts that I've gotten replaced, like these two trimmer resistors and these two caps right here, which I had to put back in the originals. I actually got the non-polarized versions and got those installed. And I've changed out, like I said, the differential pairs and the current mirror transistors in here as well. So all this stuff is new. Excuse me. I replaced this trimmer, and I also replaced that trimmer as well because I got those in. So all the trimmers are new. If you can remember from the previous videos, they were pretty rusty and crusty, so I want to make sure I got new ones in there. So, okay, let's get back to this bias thing. So here's the adjustment page in the user guide, and it's pretty simple on this particular unit. So why do we adjust the bias on the transistors? Well, pardon me, I seem to have something in my throat. So you got an NPN and a PNP. This is what's set up in what's known as a push-pull configuration. So on the positive end of the signal gets amplified by this transistor, the negative side of the signal gets amplified by this transistor. So what they do is they switch back and forth. Well, if you don't bias these transistors and get a little bit of current flowing on them before the switch happens, it gets what's known as crossover distortion. And so what the bias does, it just gives a little bit of quiescent current, kind of like a little cushion. So the transistor is already slightly conducting when they switch over back and forth, and then you don't get that that crossover distortion. So that's what we're doing right now. Let's get back to the service guide. So this is a pretty easy adjustment. You've got the two emitter resistors for one channel, two for the other channel. So you're going to set up your probes accordingly. You get positive on this side. I'm sorry, negative this side, positive on this side. And it really doesn't matter how you set up the polarity. All it's really going to do is just change what direction the meter is going. You still want the needle to swing in the same direction. And in my case, I'm using a digital multimeter. So the only difference is it's going to put like a minus sign in front of the number if I have the cables hooked up backwards. So again, polarity is not super important. So you got your two variable resistors that you're going to be using to make the adjustment. And this is a prerequisite here. You want to have the balance in the center, you want to have the volume turned all the way down, and you want the power switch on to speaker set A. And the goal is to turn the trimmer potentiometers until the meter indicates somewhere around 15 millivolts. Okay? So I got the prerequisites all done. I don't have the faceplate on this unit right now, but if you look at the faceplate, the power switch, you get power off, you get your headphones, and you got your speaker A. So I know by turning this 2 clicks, I'll be on speaker A. So yeah, let's go ahead and hook up the probes. And like I said, I'm not going to pay attention to polarity here. I'm just going to hook them up, one on the far side of each one of the emitter resistors. And that way I should just be able to get my measurement. I don't really care much about polarity. I know what I'm measuring for. So here we go. All right, those two guys are set up there on that channel. I've got my multimeter set up to measure millivolts DC. So we'll do 1 click. And we get nothing. Well, that's probably because I need to plug this thing in. So hang on a second. Plug. Who's got the plug? Do this all one-handed. Takes some mad skills. All right. Try it again. Click 1, on. Click 2. We're on speaker A. Okay? So here's what we got right now. You've got 0.4 millivolts DC, so that's like really super low. Our goal is to get it around 15 millivolts DC. So I'm going to take my plastic tuner, because you never want to use a metal screwdriver when you're adjusting these potentiometers or the coils. Big fat no-no. Okay, so let's bring it up. 15 millivolts. And we're up. Let's jump up. Oh, got a little overzealous there. 17, 16, Get it close to 15. Okay, that's close enough for me, because what you'll find is after you let this thing sit for about 15-20 minutes when it warms up, this adjustment's going to climb, and it'll stabilize after about 10 minutes. So what you want to do is just kind of get it in the ballpark, and then let it stabilize and go back and readjust it to 15 millivolts. So that side's done. Let's switch over to the other side. This guy here. All right. Get my tuning tool in the slug, preloaded. Okay. Not a slug, it's actually a variable resistor. Okay, so we're 0.4 millivolts. We want to be up to 15. 2, 12, 18. Dang, that thing climbs quick. Adjustment's a little bit touchy here. 15.9, 14.7, 6. I am just barely touching this thing. And these are brand new trimmers too. Still really touchy. Okay, we're going to call that done. I'm going to let this sit for about 15 minutes or so, and I'll come back and readjust it, and that's it. That's setting the DC bias on this particular receiver. And I'll be back, and we'll wrap this thing up. So what I want to do is just kind of show you what I've done so far and kind of what's left and what the plans are for this unit to finish it up. So first thing I did is, since this section I had already repaired and I recapped, and I did the DC bias setting, so that's all done. I went over here to the preamp and receiver circuit and I recapped this entire board. There was a whole bunch of very low valued electrolytic caps, which I replaced with these film caps. So these are superior both in performance and also in longevity. So they'll outlast the life of this unit. And so those have all been replaced, along with all the electrolytics. I got a couple of audio grade caps back here because these two were directly in the audio path. And so we've got these connectors here. I've got another one here, and there's another one back over here. I've got to take those off because they do slide off, and I'm going to clean up those contacts and put them back on. And oh, I did a tuner alignment also, but before I did the tuner alignment, I cleaned up the fins on this tuning cap, and I also cleaned up the contacts on this part of the shaft that rotates. There are some contacts that connect here, here, and here on these points, and I cleaned those up as well, because if those get dirty and the contact is bad, you'll find that the FM tuner and the AM tuner get a lot of static when you're trying to bring in a station. And so I cleaned those up. Now, a lot of people don't use tuners anymore, but most folks that are interested in these older units, that makes a nice sound. Most people that are interested in these older units are interested in using the tuners as well. And this one actually works really well once it was aligned and tuned up. It wasn't really far out, but it was out enough, and I was able to improve its ability to pull in weak stations. So what's left to do? Oh wait, there's one other thing I did, and I'll show you over on this side. The power switch. Okay, the power switch on these things are notorious for wearing out. The way Kenwood has them wired up is they have the 120 volts coming from the mains into the switch, and then the other side of the switch goes out to the transformer to power up the rest of the unit, which is all fine and dandy, except you're carrying a lot of current through this mechanical switch. And when you're turning it on and off and on and off and on and off, there's a lot of arcing that happens in between the switch contacts, and over time they get worn out and pitted. And so these power switches are a common point of failure for a lot of Kenwoods. This model and some of the upper models as well. So there's a modification that you can do using a Triac. Now, a Triac is a solid state device that can be used as an AC switch. And so I found a nice little spot on a heatsink right here, and I mounted this Triac. And so what it basically does is I've got the input from the 120 volts, and then this is going out to the other side of the transformer. So this is now in series with the mains as opposed to the mechanical switch. So all the mechanical switch over here is doing is just switching a very small amount of current to turn this device on and off. And so all the heavy lifting is done here, and there's nothing but light little switching done at that power switch. So that's going to make that thing last forever. And this Triac is way overrated for its current duty in this circuit. So it's going to last a long time as well. So let me see what's left. I checked all the lights. All the light bulbs work good. not going to replace them because they're not bad. I was thinking about an LED upgrade on this thing, but again, I really like the look of the incandescents on these older machines. When you put the LEDs in there, they get too bright and they look unnatural. So I like to keep the bulbs in there. So I think the last thing I'll do is clean up these RCA jacks. And I've got a technique for doing that. Basically, I take my drill right here and I chuck up a 9mm deep socket. And I have these little material pads, which basically I make out of old socks. As you can see here in the scissors, I cut these little pads out. So I stuff the pad inside of the socket, right here, and then I spray the pad with some deoxit cleaner, and then I put the socket over the outside of this, and I spin it for a little while, and that cleans and polishes the outside really nice. And for the inside, I just take this set of baby bottle cleaners, which I have, and this one right here is a really good fit for the center part of these RCA jacks, and that just goes in there with a little bit of cleaner. Clean those out, and we're good to go. So that's what I'm going to do. Clean those connectors, clean these connectors. I'm going to button it up, and then I'll run it and burn it in, test it out, make sure it's working good, and it will be ready for its new owner. Right now I've got it set on to speaker A. It's turned on. I've got all the tone controls and balance centered out, volume's all the way down, and I got this sitting over on auxiliary, and I have no input going into it. So in the back I've got my speaker terminals and just some little wires that I can easily attach to these speaker terminals with my voltmeter cable. So I got the voltmeter connected to the left set of speakers right now, and we're measuring, I'm going to call it 23 millivolts. Okay, that's really good. That's pretty dang close to zero. So let's check the right channel, see how the right channel is doing. And again, this there's a negative sign in front because I have the polarity of the connectors going backwards. Got positive on negative, negative on positive. So that's all that is. So let's make it right for the right channel. See what I did there? All right, hooking it up. And right channel, we're looking at about 17. I'll call that 17, close to 18 millivolts. So yeah, that looks great. So the thing is performing wonderfully in that regard. So let's disconnect these. And now let's check the output power and distortion. I want to see how much power this thing puts out now that I have the larger output transistors installed and everything's balanced out. So let's do that. So now that we've got DC offset done, I want to measure the output of this receiver and see how much power it puts out before it clips. And so I'll show you the basic test setup for that. So I've got my 2955 setup. It's in AF generator mode, so the audio analyzer screen is up. And I'm going to be generating a tone at 1 kilohertz. The level is going to be 100 millivolts. Okay, and that's going to go out through this AF output generator, and it's going to connect into the back of the receiver right here. This is the auxiliary input of the receiver on the left hand channel. We're measuring the left hand channel. So the left hand channel is connected here, and it kind of goes around this little squirrely cable and hooks up to this connector. I use this for commercial audio amps too. That's why I have this this little jack on here. So I got some clip leads on it. These are this is my 8 ohm dummy load. It's actually 2 4 ohm dummy loads connected in series to make 8 ohms. Then I have these clip leads back here that I'm actually going to be using for measurement. And those kind of wrap all the way around, and they go to the back to my HP 34401, and I'm measuring AC millivolts, and I have this depressed so that it uses the terminals in the back and not the ones in the front. And then from there it comes around, goes through the scope, which I'm not using right now because I've had some trouble with it and I need to do some work on it. So fortunately, I do have a scope in my audio analyzer as well. So that goes around to the input, and we're going to be performing our measurement there. So it's all hooked up and ready to go. We're generating a signal. So what I'm going to do is I'm going to adjust the power on this, and we're going to check the output here. And I'm sorry, I know it's annoying that this thing is wavering about. And so let's just bring it up. And we'll bring it up to right where it starts to cut off. See where it's flat top in there? That we're getting distortion, so we need to back down to where the distortion just stops, right about there. And so we're measuring, what are we measuring? Can't even see. Okay, it's 20, I call that 20.3. volts AC. So how do we get the power? Well, we go to our handy dandy calculator. We take 20.3 multiplied by itself, 20.3, so that's 20.3 squared equals 41209, and we divide that into 8 ohms. And so this is putting out about 51 watts. Okay, so factory, this thing is rated at 40 watts. So we've gained an extra 10 watts out of replacing those output transistors with ones that could handle a bit more current. And that signal's nice and clean, and here we can hear it being amplified there. So that's great. So that's the right channel. Let's go ahead and measure the left channel. So I'm going to turn this down. And so what we'll do is we'll switch this connector, and we'll put this connector in the right channel, and then we'll switch these down here so that we're measuring the right channel. Okay, all set. So now let's do the same thing. Let's we'll turn up the volume, which is right here, and up we go. Trying to get the reflection of the garage out of there. Okay, up, 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 up. Okay, now we're into distortion. I'll back it down. Yeah, so about the same thing, about 20.3. So we're 50 watts per channel. And then we can check the linearity of the balance. So if I shift the balance off to the left-hand side, we'll see the signal drop down nice and smooth, and it does come back up just like that. So the balance is working well. Volume is nice and linear. So let's call that a wrap. I think what I'll do is I'll play a little bit of music through here. I'll see if I can download some clips from YouTube, stuff that's not going to get me cited for copyright violation, and give you a little sample of what it sounds like. I'll also hook up the FM tuner, and we'll kind of flip through some stations, and we'll see how that works. What a handsome receiver it is. I mean, you got to admit, Kenwood did a really nice job with the front panel on this. It's got the nice big aluminum knurled knobs, all shiny. The face is laid out real well. I like the illumination. Just a really attractive receiver. So I was going to paint this outside, but I just decided that I would leave it like it is. It has a coating on it. I don't want to say it's kind of like a vinyl coating, but I'm not sure if it's actually laid on or if it's sprayed on. But I managed to clean it up fairly decent. I mean, it was an absolute mess when I got it, so it cleaned up pretty nice, I thought. So I thought I'd just go ahead and leave it be. So what I have here is I have it hooked up to my my test speakers here. I got a couple little JBL Pro 3s, one on each side. I've had these things since probably the late 80s, and I've had to put new surrounds on the woofers, and I've recapped them, and they make great little test speakers. So I've got it hooked up to those, and I have my little pad set up on YouTube to some non-copyrighted, energetic and upbeat background music for videos. And so we're going to use that as a way to kind of sample the way this thing sounds. And I know you're not going to get the true sound over YouTube, but at least you'll be able to hear that it works. And we'll mess around with some of the tone controls and the balance and the loudness and all those things. First thing we'll do is I've got the FM receiver on. We're tuned into a station. It's decoding stereo. Not a whole lot of signal strength there. I've got a makeshift antenna. Okay, this is like a lousy excuse for a homemade dipole. And plus I have it mounted right next to this overhead light, which is a fluorescent light. So you get a huge amount of 60-cycle hum if any of my lights or equipment are on. So that's why everything's shut off and it looks a little dark in here. But anyways, let's turn up the volume here. And
fresh for everyone.
What's with the shovel? Stop!
There you go.
What?
Yeah, so we'll scan down a little bit. Oh, and I also got this dial, got it straightened out. It was all wobbly, if you remember, so that's all straightened out. So you can see as we turn out of the station, we get the fine-tuning indicator. It locks it right in. I'll just kind of go down the dial here.
McDonald's is here.
Oh, yeah. There's no one. Oh, a lot of Hispanic stations around here. Oh, they're great notes. Okay, so that's the FM tuner. Well, let me turn that down, and I'm going to turn this thing to auxiliary. And we'll turn up the volume a little bit. And we'll make sure the volume's set all the way up on this device, so we get maximum input. Now let's go ahead and press play. Hear what we got. What do you think? Is that lively and upbeat? Okay, so we'll do the bass. That's boost, middle, cut, treble. We got boost, cut, middle, balance to the right, balance to the left, loudness. Yeah, so everything's working great. Let's go ahead and test the phono inputs. Hang on a second while I switch this thing around. So right now you might be thinking to yourself, did he get these videos out of order? Why is this thing up on its side with the covers off again? I mean, last I left, I was checking the phono section to see if it worked. Well, that's exactly what I did. And what I found is one of the sides was much more quiet than the other one. So after checking all my cables and wiggling them around and making sure everything was fine and substituting here and substituting there, I came to the conclusion that there's a problem in the circuit. So I had to pull the covers back off and do some checking and jump back into the schematic and to show you what I found. So in the audio preamp circuit, where it's using two op-amp ICs, and there it's the Toshiba TA7136AP. Pretty common op-amp to be used. You'll find these in receivers. They use them in the preamp tone section. They use them as phono preamps, and you'll also find them in early guitar pedals, guitar effect pedals. They use them quite a bit in there. So the problem is these things are unobtainium. You can't really get them anymore. And if you do, you've got to buy them on a used market, and you're never sure if they're good or not until you actually install them in the circuit, and then you find out if you got ripped off or not. So this was kind of a blessing and a curse, because this gives me an opportunity to upgrade these op-amp circuits to modern ones that actually have a lower noise floor, better sound characteristics, better frequency response, and give you a better overall sound from the phono preamp. And so we'll just pop those in, right? What's the problem? Well, not quite as easy as all that. So let's take a look at the 7136 pinout. Okay, so it's a single inline chip, and there's 7 pins on it. The OPA 604, which is the op-amp that I chose because it has the same characteristics as far as supply voltages and input impedance and such. Here's the package that it comes in. Okay, this is a surface mount device. It also comes in a through hole, but how am I going to get this to work with this? You may be asking yourselves. Well, I'm glad you asked. There's a company called Brown Dog, and they make these cool little adapters. And here's one right here, and this is made specifically for this purpose. So you can see we've got the 7-pin inline package, and then on the actual adapter chip you have the pads to mount either a surface mount device or a through-hole device. So I purchased the surface mount versions of the 604 because they're more readily available and they're a little bit cheaper. And I wanted to kind of test my surface mount soldering skills. So there you go. Anyways, I'm going to tack these babies on here. The cool thing about these is there are certain pins on the circuitry for the 7136 that you no longer need to use, because the modern op amps have internal compensation, so they don't require some of the external components. And this adapter actually eliminates those pins, and there's also some pins that you have to switch around, which are all done by the adapter. So it's a really easy thing. Just solder them on there, insert them in the circuit. Of course, you have to make sure you get pin 1 and pin 7 correct, but that's really all you got to do. So I'm going to slap these on here. I'm going to put them in the circuit, test it out, and see how it works, and be back shortly. Stay tuned. Oh, you know what? I totally forgot that I was going to show you how I tested these things. So I'll show you real quick. So I've got the audio output of my audio generator at 1 kilohertz, and I've got the signal level at 10 millivolts. Normally I test at 100 millivolts, but this is an audio preamp and it's very sensitive, so you got to use very small signals. And I think, like I said before, that's probably what happened. Somebody put something too strong here and blew these things out. So the two ICs that we need to test, IC4 is here and IC5 is here. So IC5 is a good one, IC4 is one that's defective. So we'll do the good one first. And so here is pin 2. That's our input. So you can see our input is it's rather small. It's pretty noisy too because it is a small signal, and I've got overhead fluorescent lights going. So that's all the distortion that you're seeing. And let's see, we'll go here to pin 6, which is our output. And as you can see, the output is significantly larger. I'm not going to adjust the scope to show you what the output looks like because I've got one hand on the probe and another hand on the phone. But take my word for it, it's a clean output signal, and this side is working like it should. Okay, so let's go to the other side, and we'll do pin 2 here. There's our input signal. It's the same as the other. And we'll go back here to pin number 6, which is our output. And yeah, see, it's just barely being amplified. So this is a defective device. And so once I get back, both of them hopefully will look like each other, and they'll be amplifying and working brilliantly. Okay, here you go. A little shaky, but I'll tell you what, not for the faint of heart. If you're thinking about getting one of these boards and testing out your soldering skills with the surface mount components, I would urge you, if you're the type of person who likes to hurl things and scream out expletives while you do it, I wouldn't attempt this. I mean, I've got some pretty decent soldering equipment. I got a Metcal temp controlled station. I got the right size tips. I've got the proper diameter solder wire and magnifying glasses, and I'll tell you what, it was a struggle to get this done. Spend the extra money or wait the extra time, get the through-hole stuff, and go easy on yourself. Just as promised, we're back. And to the magic of movies and film, it looks like this thing never moved, but actually I did install the adapters, and so there they are. We're right here, and we're right here. Now you'll notice pin number 5, there's no solder on pin number 5. Okay, that's because pin number 1 and pin number 5 are no longer necessary. On the previous IC, they were used for compensation, and that's not necessary to do on the modern component. So I removed the accompanying components from pin 1, and I just left pin 5 unsoldered because it doesn't need to be soldered. So these are the only connections that we need to make. Also, one of the pads came up on one of these capacitors, so I had to put a jumper wire here in its place. And but everything's good. Everything's back to normal. So if you remember, this was a good one. So let's go ahead and test the one that we replaced that was bad before. I'll put my scope probe on here, and we'll probe out pin number 2, which is our input. And you can see the small signal. Come on, focus, baby, focus. There we go. And pin number 6. Ta-da! Looks just like the other side. So this thing's working, and it's working awesome. And I'm looking forward to testing it and see what it sounds like. So let's have a look to see what these ICs look like when they're installed. So we are right here for IC4 and right here for IC5. And I'll get from this angle so you can actually see the op amps that are soldered in there. So these adapters are great. They just dropped right in where the other ICs went. And here are the components that came out with some of the caps that are no longer needed for compensation. So that's it. Job done. I'm going to button this thing up, and I'm going to test the Phono inputs once again, just to make sure that they're still good. And that'll be it. This will be done. So I'll be back shortly. All right, so I get this thing buttoned up, and you know what? If we're going to test the Phono input, let's test the Phono input properly with a phonograph and a record on the phonograph playing through the Phono inputs. Okay, did I beat a dead horse? I think I did. Anyways, I got my little Philips 312 turntable in here. This has been called the poor man's Thorens because of the suspension system it has, and it's a very light compliance tone arm on it. And as you can see, the whole thing is suspended inside on springs, so it works rather well. So anyway, I got this set up on Phono. Got the loudness turned off. I get the volume probably about a quarter of the way And these two controls, balance and treble, are centered. I gave a little bit of bass because these speakers are kind of small. And I got the power turned on, set to speaker channel A. So let's drop this needle down here and give it a listen. All right, we'll hit this little touch tone button. Pretty cool, huh? And let's just drop this on here for some sweet sounds. Here we go. Back it up a little. Get the whole sound. Stopped by a diner and a blonde behind the counter asked if she could help in any way. All right, that's enough of that. So as you can see, it works well, and I really like this little receiver, and someone's going to be the new owner of it. And I just want to thank you all for taking the time to kind of hang out with me. You know, it gets lonely in here working in the garage by yourself, so it's kind of cool to have people to hang out with while I'm working on this stuff. So hopefully you've learned something, and I'll have more things to come, so we'll see you down the road.